Okay, well today what we're going to talk about is 4-1, which is using graphs to relate two quantities. Okay, our objective for today is to represent mathematical relationships using those graphs. And our standard today is A1.5.5, which is to sketch and interpret linear and nonlinear graphs representing situations. So we're going to be dealing with a lot of story problems in these next couple sections. Okay, the first problem that we have is the graph shows the volume of a balloon, air in a balloon, as you blow it up until it pops. What are the variables? And then describe how the variables relate at various points on the graph. So basically, you're just describing the story problem based on the limited information that you have. So you'll notice that we have time in the x-axis and volume in the y-axis on the graph. And then there's just some representation. So basically, you're just describing that. Well, what are the variables? So what are the things that change over time that change throughout the story problem? Well, the variables in this case are going to be, well, first off is going to be the time. Okay, as time changes, the volume changed. So therefore, what changed? Well, the time and volume. Okay, that's what's changing. Now, as we talk about that, describe how the variables relate. Well, at the beginning, there's no air in the balloon. So down here, there's no air in the balloon. Then as you're seeing that, all of a sudden we have this line go up, and then it stays at this height. So that means the volume stayed the same from here to here. So basically, what we're saying is, as you blow air into the balloon, okay, the volume increases. So that's how the variables change. So as you blow air in the balloon, the volume changes, or increases, we should say. And you're going to notice that it stays constant when you're taking your breath. So as you blow in the balloon, you breathe out, and then you stop, you pinch it, you hold on, you breathe back in some air, and then you blow it back into the balloon. So there's that constant. So it remains constant as you're breathing. And then it gets to a point where it pops. So when the balloon pops, the volume goes to 0. So that's all they're really looking for you to do, is just to kind of describe what's going on. So as you blow in, the volume increases. It stays constant as it doesn't as you're breathing, to catch your breath back in. So it's just kind of how that is being displayed. So you can envision that this balloon is going bigger, and then you're breathing and you're blowing in, it's getting bigger, and then you're breathing in, and then it eventually just pops, and then it drops down to 0. So that's important to know, that this line shows the instantaneous drop back down to 0. Okay, so example 2 here, analyze the graph. What I want you to do here is, you have a board length. So they're talking about a piece of lumber, and they're talking about the board length over time. So kind of in your own words, tell me what the variables are based off this graph, and then also go through and kind of give what the representations are. So what does this line mean, and then what's this line mean? Okay, what's that in relation to two variables that you come up with, kind of what we just did with the balloon. Okay, the other thing we're going to do is going to be matching up a table and a graph. So it says a band allowed fans to download its new video from its website. The table shows the number of downloads after 1, 2, 3, and 4 days. Okay, which graph could represent the data shown in the table? So we see in the table that day 1 there was 346 downloads. So obviously there's some word of mouth going on. People are talking about it. And then day 2 we're up to 1,011 downloads. And then day 3 we're at 3,455. Day 4 we're at 10,426. So which one does that represent? Well, there's an obvious increase over days. So as you look, and this would be our D we could throw out, because as we go day 1, day 2, day 3, day 4, we're decreasing in the total downloads. So therefore this one we could just throw out. Okay, and then as we go up and we start looking at it, this one's showing a representation of an increase, so this would be our A. There's a representation of a constant increase, which means from day 1 to day 2 there's the same amount of increase. Well, it looks like there's about, let's say, 700 downloads here. From here there's 2,000 different downloads. So therefore from here to here it's not constant. So therefore A can be thrown out because this is showing that there's the same increase each day. And here there's a plus 700, here's a plus 2,000. So we're down to these two, okay, which this would be B and C. When we look at C and B here, C shows that there's an increase and then it kind of tapers off. Well, if we look at the later two, again this was 2,000 increase, this was increased to about, roughly 7,000. So that's a huge increase compared to this one. This was only 2,000, this was 7,000. So this is saying that we had a big increase but then we tapered off. So it wouldn't be C, it would have to be B, because we started here, we increased slightly, we increased greater, and then we increase even more. So it has this increase that goes up kind of like this. So this one would be B because it's representing that increase as we go. Okay, so that's how we kind of match up. You look and analyze the data and you analyze the points. Even though they didn't give us, the numbers on our X and Y axis here, we're able to display it and kind of reason it out. Okay, and the last problem here as we look at is being able to represent a situation and put it into sketching a graph. So this is kind of the easy part because there's a lot of different ways you could represent this. I mean, they should all be about the same, but it says that a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to the earth. I just want us to sketch it and then label each section. So basically it's a hybrid between problem number 1 and this. Okay, so the first thing is we said a rocket rises quickly. So let's imagine that we're outside, maybe in science class, and we're going to be shooting off rockets. We're going to call this time. As you saw in a lot of the other problems, time, hours, minutes was down on the bottom. Then what we're going to do is we're going to say this side here is going to be our height. So our height of the rocket. So right here would be 0, 0, which means what? Well, that means that that's basically at time of liftoff. So we'll go ahead and kind of label that. That's liftoff. Now the rocket's going to shoot off, and it's over a period of seconds here. It's going to increase in height greatly. And then it's going to slow to a stop as it starts to lose fuel. So what's going to happen is we're going to reach a high peak, and then right here basically is our stopping point. This is where we would say it stopped. It ran out of fuel, it stopped. And then what happens is it's going to fall, which means decreasing height. So up here's the maximum height we reach. So it decreases greatly. And then it says at some point right in here, okay, as we were falling, so we'll call this section the fall, we release that parachute. Okay, so we can say right here is where the parachute hits or comes out, and then we're going to have this constant drop. My line wasn't very straight there, but we're going to have a constant drop as we go through. Wow, that's even worse. Okay, so let me get out a little line feature here. Redraw that. There we go. It's going to drop at a constant rate now. So it's not falling as quickly, it's just going to slowly drop. Okay, so that's where we're going to fall and release slowly, and then until we hit the ground. So this is how we can represent it. And again, all they're asking is to label each section. It's basically what we're doing here. The only other one we should write is rise. So all we're doing is representing the data as it goes through, which makes sense. We rise really quick, we hit a stopping point where it reached its max height, and then it turned over and just fell back down to the earth until it reached a point where the parachute released out and then it just kind of steadily floats down to the ground, and then right there's where our height is, okay, over a course amount of time. Okay, so we're just doing a lot of investigation of graphs in this section. So as you go through, you have to think about the story problems. You can't just abandon them and not even try them. It's going to take some thought. You have to kind of decipher what the meaning is, and you almost have to kind of make up your own meaning a little bit in some sections. Okay, well there's a quick one-question assessment that I want you to do on Edmodo. Okay, so you need to log into Edmodo. You'll find there's a Ch.4-1 quick question, and when you open up that document, look at that. If you have any issues, make sure you post something in Edmodo and let me know. And then what I want you to do is take that one question quiz. It's a multiple choice quiz just to answer that. Okay, so you have to look at the document to get the information, then you're going to select your answer, and you're going to submit that in the quiz. Okay, that needs to be done before class tomorrow. Okay, we'll stop there for today, and we'll talk more tomorrow in class.